Hello everyone, welcome to AI Anytime channel. In this video, we are going to look at Giskard. So Giskard is a testing framework that helps you evaluate machine learning models and recently the large language models. So using Giskard, you can find out the biases, the hallucination rates, and different other metrics that you can, look at to evaluate these AI and machine learning models. And it's really amazing because they have created n numbers of high-level abstract classes. So you don't have to write a lot of code. Okay, so you can just use their high-level APIs and you can build it, the tool that you want to build for evaluating the LLMs. Now, if you look at Giskard over here on the GitHub repository, it says the testing framework dedicated to ML models from tabular to LLMs. Trust me, this is the best tool I have seen in the last few years when it comes to evaluating AI and machine learning models. For LLMs, we have a lot of qualitative measures. It's based on qualities. That's not always you need. For example, ragas. You have ragas, you have GPT eval, you have GPT score, etc., etc. Those are more of the qualitative metrics. Okay, when you work for an enterprise, when you work for a regulatory industry, qualitative measures will not help you. You need quantitative measures to evaluate these LLMs. You have to go a little old school and start looking at the accuracy, F1 score, recall, precision, mainly the confusion metrics. When I say it, trust me, you need confusion metrics for your vector retrievals, the rags, etc., etc. You can do that. There is a mechanism that how you can do it. And this is what we are covering in the evaluation playlist that we have created on my channel, right? Where I'm creating videos on only for evaluating RAGs and LLMs. Now, Giskard is being part of that. You can look at here, it says scan AI models to detect risk of biases, performance issues, and errors. You can find out all of the issues with your RAG approach or the model that you are using. So, for example, if you are using OpenAI or Vertex AI models, you can just find out if there is any chance of bias. For bias, I already created a video the other day, which is based on V8 word embeddings association test and the demographic diversity analysis. Please watch that video. I'll give you the link in the description. Now, let's start our exploration with Giskard. You can see this is a very good. Uh, it's not a magic because you can still do it algorithmically, writing a lot of code, using cosine similarity, finding out the accuracy, recall, using bird score, using different scores that you can use. But here the way of representation, the way they are presenting the message to the end user about number of issues detected based on four different categories: performance, robustness, overconfidence, and spurious correlation. Okay, so for spurious correlation, overconfidence, robustness, and performance, these are the four major categories that Giskard provides you. And within those performance, you can find out the accuracy, recall, precision, etc., etc. In the robustness, you can look at the perturbation in the input data, etc. So now let's start our exploration with Giskard. I'm going to do this in my Colab notebook because that's where they provide their display features, etc., where you can just look at that. Now first thing that you're going to do is I'm going to install pip install, and I need, let's basically get this here from Giskard, the pip install thingy. At least I need a particular version that I have noted it down in my notebook. I'll just have a look. So, but anyway, let's first get Giskard and let me look at my notebook. We need this because we're only looking at LLM here. You can do a full installation for Giskard as well. But here I'm just going to do pip install, and then you need greater than equals to 2.0.0b. This is the version that we need for Giskard, and then you just do, and then you just have to do upgrade. Okay, let me, this should be in a double quotes, otherwise it will give you an error. Now here I'm just going to do an upgrade if there's any installation already there. Now I'll just do pip install Giskard LLM. It will install me for that. Now I also have to install a couple of few things because here we're going to do a RAG implementation, guys. So we're implementing RAG here, and in this RAG we're going to use FAS as a vector store, which is an in-memory vector store. We're going to use PyPDF that will help you extract the text out of a PDF file, and we're going to use tick token, OpenAI, and a couple of other dependencies. So let's start our those installation as well. So I'm going to do here is pip install, and the first thing is LangChain, because LangChain as being an orchestration framework. So let's do pip install LangChain, and then PyPDF. So PyPDF, and then I'm going to do FAS. I'm going to rely on the CPU thingy of FAS. So FAS CPU, OpenAI, and again, if you just do OpenAI install, because there are a lot of changes has happened. I mean, yesterday there was a OpenAI first development day, the dev day, and we'll create a video on that. Because there are already a lot of videos, so it doesn't make sense. But so there are a lot of changes that has happened. So you have to install a particular version of OpenAI to not get errors. Okay, that is for 27. So 0.27.0, and then tick token. Now let's install these things here in our system. Now after that, I'm gonna import couple of things. Okay, let me just come down because it's gonna install. So let's do import OS. The first thing that we need from path lib import path, and then let's import uh we need import OpenAI. Then what we need is import pandas, maybe add PD, and now from orchestration framework. So from langchain.llms, import OpenAI. Okay, I don't need all this. That's the problem with now. Generative AI has been integrated into Colab. Now from langchain.llms import OpenAI. Maybe I can also get the chat model if we need. So from langchain.chat underscore models, let's get that import chat OpenAI. Chat OpenAI, and what else we need from langchain dot let's get the base chain. So chains dot base import chain. I don't know why it's suggesting all this thing. Okay. Now this is right. Now from langchain dot vector store. So vector stores, from langchain dot vector stores, import fas. We need fas here. And then from langchain dot prompts, import prompt template. This is what I'm gonna do. Now from langchain, prompt is done. Now the embeddings thing. We need an embeddings model as well. We're gonna use ada002. So from langchain.embeddings, and you're gonna just do import open. No, this is not how we write. It's caps. Okay, open AI embeddings. Okay, now from langchain dot document store, because we're gonna use PDF thingy. So document loaders, document loaders. I said document store. Import PyPDF loader. And from langchain dot chains, import retrieval QH and load chain. Let's also get a load chain, and recursive character for chunking. So from langchain dot text splitter, import recursive character text splitter. Recursive character text splitter. Okay, and now the Giskard thing. So let me just give a gap there. So from Giskard, we're gonna need couple of things. So from Giskard import, first is the data set. We're gonna create our own data set before we feed it to the Giskard high level classes. Then we need model, then we need scan, and then we need Giskard client that will help us initiate a Giskard client. And here we go, we successfully imported it. Okay, now OpenAI dot API underscore key. There are two ways you can do that. I can show you that how you can basically bring uh, like you can set an environment, or you can just do it from an env file. So this is one way of doing it. The other way can be like you just do os dot env, for example, os dot env, and you can set your OpenAI API key somewhere. For example, if you have, you can just do it like this as well. Now if you do this, you can also set it like this. So both way you can just do it. Okay, like you can set your OpenAI API keys. Now let's do pd.set option. We're gonna set the display option, because we're gonna display this scans and all of those things, right? So set option, and let's do display max column width none. Okay, now this is fine. Now let me just clean the charger. Now what we're gonna do here, guys, Here we're going to do a few things. The first thing is that we need an URL. So we are going to take this document that Giskard also recommends in their documentation, which is a climate change. And I like the document. I think we should take these use cases and build it for people to create awareness on sustainability as well. It's a report of climate change 2023. You can look at its 80 plus pages. So big enough document to create a RAG system for you. You can retrieve information. You can chat with this document, etc., etc. Now let's take this. So what I'm going to do here is I'm just going to copy this URL and we'll just do it from URL thingy. Now you can see that I have set the URL and this is my source data. And now I have to do is we have to set a LLM name. So I'm going to use Turbo here. So just let's do GPT 3.5 and Turbo. I'm not using GPT-4, but you can use GPT-4 if you want. This is your LLM name. And once you set the LLM name, let's have a text column query. Text column query. And then this is query. Text column query, and then this is query. And now I'll just set a prompt template. We'll have a very standard prompt template because the model should only return the answer from this the context that we are creating. So we create a doc string here, and in the doc string I think there's one more extra, and here let's write you are the climate assistant, a helpful assistant made by Giskard, something like this. Okay, your task is to answer common questions on climate change. Okay, you will be given a question and relevant excerpts from the IPCC climate change synthesis report 2023, and please provide short and clear answers based on the provided context. Be polite and helpful. There's a wrong in polite spelling, by the way. Okay, so let's just write it. Be polite and helpful. And here now in the below section, what I'm going to pass is my context. So your context is nothing but the context that you're going to create, the vector embeddings. Okay, now the context, and below we have our question. The user will ask this question that will take it from the through chain. Okay, now question, and then you just give your answer. Okay, so let's just do your answer. Okay, your answer. Now this is your prompt template thingy. Now after prompt template, let's write a function called, this is the first initial context storage. Okay, so let's use get context storage, create a function, and in this function I'm gonna just basically use fast here. So let's just use fast. Okay, and in the fast thingy, now what I'm gonna do is I'm gonna initialize a vector storage of embedded chunks. Okay, that we're gonna create. Now text splitter, and I'm gonna use recursive character text splitter, and then here we'll have our chunk size and all. So let's just define chunk size, and we'll keep a bigger chunk size, 1000 as chunk size, and then we're gonna have chunk overlap. So chunk overlap, how many chunk you want to overlap it. I'm gonna just do 100 for example. When you have 1000, the intuition is to keep 100 as chunk overlap, and let also add start index. So add start index equals to true. It's a boolean value. Okay, now here we don't need right now here. Okay, now here what we're gonna do is docs equals py-pdf loader, and inside this py-pdf loader what we're gonna do is now we have to take it from URL. So let's give it URL. Okay, because you can also get it from URL. And then let's use load and split right here. Okay, so load and split, yes, it has load and split, and you can pass the text splitter thingy just right there. and and then db equals, you're gonna do fast. Ooh, fast dot from documents, and here you're gonna pass docs. Not only docs, right? Pass the OpenAI embeddings. That's where we're gonna create the embeddings. You need an embeddings model that will create embeddings for all of these chunks. Okay, and then we'll return this. So let's do that here. And you can see this is what we have done. Now what we can do is we can create a simple chain. So let's create a simple chain here and see, if you are getting our thingy here. So now create chain, I'm going to do an LLM equals OpenAI. This is what we're going to do. Let's use temperature equal to 0. Let's keep it let's keep it 0.1, for example, very less, because we're just doing an information retrieval. Okay, we're not trying to our LLM to be creative. Okay, let's don't do that. Now we have our LLM set. You can use other LLMs as well. I think it also supports Vertex AI, if I'm not wrong. Now, here I'm just going to write my prompt thingy. So prompt equals, I'm going to use a prompt template, and prompt template, and not only prompt template, but I'm going to pass my input variables. So input variables, and its context and question. Okay, or let's write in the right order. Okay, so I'm just going to write, or I think it's fine. Okay, is the right order. Now context and question is my input variables. It's a Python list that you can pass. Now we have prompt thingy, guys. We have prompt. It says the positional argument are given to. Okay. Prompt template has been given. Okay. If this is how it is, so let's write template equals. This is surprising. You have to write the word template to assign map it to prompt template. Okay. Now let's create a chain, simple chain first. So climate QA chain. And in this climate QA chain, I'm going to do is, it's a retrieval chain. So let's do a retrieval QA chain. And inside this retrieval QA chain, the first thing I'm going to do is, or, I'm making a mistake. It's not only retrieval QA, dot from LLM. Okay. So dot from LLM. So dot from, it is so surprising, not showing also. Okay. From LLM. Now here I'm going to pass my LLM equals LLM, and whoo, and then I'm going to pass my retriever, so which is a function that we have created. So retriever, and the retriever equals is the get context storage. Okay, so let's do that. Now the pass the get context storage over here. This is what I'm going to pass, and now I'm just going to do it as a retriever here. Okay, so let's do dot as a retriever. We're going to use that method uh, as a retriever. Okay, now this is a function, and I'm gonna then pass my prompt equals prompt, and here we go. We are done with our chain, guys. Okay, now let me just remove this thingy, and let me just remove this, and let's run it. It's a name, LLM is not defined. Okay, let's make it defined. Okay. It says OpenAI embedding when missing one required personal argument text. Okay. And we don't need this retriever as well. Let me first remove this retriever. Okay, so this is fine. We have that retriever. So retriever equals LLM get context storage dot as retriever, and then prompt equals prompt. Now here, what I'm doing is text splitter, recursive character text splitter. You have chunk size, you have chunk add start index, then docs equals py pdf loader url dot load. This is completely fine. Then db equals fast dot from documents, and then passing it's the function. Okay, it's a function that we have to give. This is so bad. Okay. Whew. It's a function, OpenAI embeddings. It's not only the keyword. Maybe I got confused. So you can also do it through LangChain expression language, guys. If you want, you can also follow that taxonomy of how you define. Now you can see we have our climate QA chain. Now if I print my climate QA chain, it should show me a rag chain kind of a thing here. Okay, so when you print it, it will show you a retrieval QA, which is you can find out all the verbose description within this chain. Now what I'm gonna do here is let's try it out. So I'm gonna do climate QA chain and let's ask a question inside this. So I'm going to ask is sea level is sea level rise avoidable? Can we avoid it? Okay, when will it stop or something like this? Okay, you can see that we got our response. It says, is sea level rise avoidable? When will it stop? It says, sea level rise is unavoidable due to ongoing effects of climate change. It will continue for millennia, but the rate and extent of sea level rise depend on future emissions. Higher greenhouse gas emission leads to larger and faster sea level rise. Therefore, it is crucial to reduce emissions and take strong and early responses to mitigate the impacts of sea level rise. Now, let's start our Giskard thingy, guys. So we're gonna define a custom Giskard wrapper module for the serialization. So let's create a class here, and for this class, I'm gonna call it a fast rag model. Okay, let's call this fast rag model, and inside this, I'm gonna pass my model, and here let's write a function called define model underscore predict, and it will take a self dot or self and then df because we're going to create a data format, df period dot data frame, period dot data frame, and this is define column text column query apply climate, or let's make it a little different. Now pd data frame we are fine. Now we're going to directly return, let's use lambda here, so return df, and then I'm going to write text column query and then dot apply, and here in the apply I'm going to use lambda and lambda x, and that becomes your self dot model dot run, that model will run on your query because x is your query. So let's define that query, and that query is nothing but your x, and it's a so if it should be in a key value pair, my bad. Okay, and this becomes your x. Okay, now this class, this first function is fine. We have a define function. Now let's have a save model thingy. So define save model. Okay, and here I'm going to write self and path. This is fine. Now here in the save model, what we're going to do is we're going to create a destination output dest. Let's write output dest, and this is going to be path and self model dot save, and then let's do join. Okay, now how should we do it? Self model dot save. Self model dot save. Out dest. We have out date, and then we should do join path if there is any function like that. We have to join, yes, join path. Now I can do that. Now join path and then model.json. So let's do a model JSON here that will save everything in a JSON file. Now let's save the face-based retriever also. So we are just saving it, guys, enough. Now here in the DB, so DB equals self dot model dot retriever, uh, and let's better make it more self-explanatory. Let's call it a vector store here in this case, vector store, and then db dot save. No, we'll use save local of fast itself. Okay, so save underscore local db of self and out dash dot join path, and then let's only call this fast. It will create, you don't have to do extension, it automatically creates it for you. Okay, now this function is done. Okay, let me just remove it now. Now we have written two functions. This is a custom Giskard model wrapper that we are creating for serialization purpose. We will save it, we deserialize it, and then we'll show the scans on a display. I will display that. Now let's do a decorator of class method here. So let me just do class method. Okay, and this is fine. So define load. Okay, let me just do an enter. Define load model class path string, and let's create the chain thingy here as well. So let's let's create a chain. Okay, and then let's remove this for now. We don't need it. Let's create a source. So source equals path. This is right, and then uh, to, this is so wrong. Okay, source path. Then db equals you do fast dot load local src dot join path, and then fast join path dot fast, and then after that open AI embeddings. Open AI embeddings, and then you pass your chain, and then chain equals load chain src model.json. This is fine. Now we can also do a retriever thingy here. So retriever in the same thing. We don't have to write extra here. Now retriever db dot as retriever. Yes, correct. And then just return the chain here, guys. And this looks nice. Now this is right. Let's now run this. Okay, now we have a class, and now we'll wrap the QA chain. So let me just do a comment here. So wrap the QA chain, and inside this, I'm just going to do a Giskard. Let's have a variable called Giskard model, and I'm going to use yes, fast rag model, and maybe fast rag model. The first thing is model equals climate QA chain, and you have to write model type. Like if you remember transformer pipeline, right? We define pipeline, and in that we write some model type, task type, etc., etc. Now model type can be a classification. It can be because Giskard also supports tabular data. It supports classification model, regression models from scikit-learn, etc., etc. You can also do that. But here in this case, it is text generation that we are looking at. So I'm going to pass text generation. Now after text generation, model is done, model type is done. The name, let's give it a name, and I'm going to call this wrapper as this chain as a climate change QA. Let's do that. Okay. Now this is my name, and then gonna give a description as well. So description equals, I'm gonna write this model answers any question about climate change based on IPCC reports. Okay, description, and then the feature names. Okay, so let me just do a feature names thingy, and the feature name is your nothing but the text column name. Okay, this is fine. Text column name is your features name. Now features name is, let me see that. Okay, it's a text column name is not defined, but we define text column, or text column query, not text column name. Okay, so that should be your text column query. Okay, let me just see that. I have my notes here. All columns of your data set. Okay, it should be all of your data set, which is your text column query. Okay, so let's call this as text column query. Okay, and you can, it's not required because it's already defined on top that. Hmm. Now this features name is right, all column of your data sets, text column query, descriptions, name, model type, model. Let's run this. It says text generation is not a valid support model types. Okay. Not hyphen. I think it's it should be underscore. Okay. Okay. Now if you do a Giskard model here, let's do that. Now if you do, it will show you it's a fast rag model. Okay, it's an object that has been created. Now we have to wrap a data frame of sample inputs to validate the model wrapping, respective to the specific test query. So let's do that. Now here in the Giskard, I'm going to create a data set for me. So Giskard data set, and here data set dot or data set pd dot data frame, pd dot data frame, and inside this I'm gonna basically use to text column query or text column query, and this, or it's not a equals a dictionary. So now here you're gonna pass a Python list. Let's write something like according to the IPCC report. What are just two, three questions? What are key risks in the Europe? Okay, now this is one question. Now the second question can be uh, is the same question that we asked. Is sea level rise avoidable? Okay, I'm asking this question. When will it stop? Okay, now this is my data set and I will test on top of it. Okay, now let's validate. So I'm going to just do print Giskard model that we have created, Giskard model, and I'm just going to do that predict on top of Giskard datasets, and then you also need the prediction. So let's do prediction here. Okay, so it should have something called prediction. Okay, fine, and let's just do that here. Now this will take a bit of time, guys, because it has to go through retrieve, find out the information, save it, create, and all of those above steps that we have done. So this might take a bit of time. So probably I think I should, and let me just write the next line of code as well. So I can pause the video and then I can explain. Now it has a scan function that we have that will help you scan all of those parameters, and that's what we are doing. So scan is the important thing. So in scan, what you have to do, you have to pass your Giskard model, Giskard datasets, and you can see the answer we got. According to the IPCC report, key risks in Europe include risk to people, economies, infrastructure, blah blah blah. Right. So the answer that we have got. Now Giskard dataset is fine. Now I'm gonna pass here only hallucination. So hallucination. Okay. Now I'm only looking at the hallucination right now. I'm not looking at the other metrics because it can take a lot of time for to run the job. Right. So I'm just gonna do results. Now in scan, what you have to pass? You have to pass a mandatory model, your LLM Giskard model, and a Giskard dataset. This would be in the Giskard format. Okay, and then only hallucination. Let's run it. It says running detector LLM implausible output detector. You can see running scan. This automatic scan will use LLM assisted detector based on GPT-4 or whatever to identify vulnerabilities in your model. These are the total estimated cost. Estimated calls to your model 30. Estimated OpenAI GPT calls for evaluation 22, and it will cost me around 0.35 US dollar. Okay, so less than a buck, I'll say less than a buck that it's gonna cost you, in the dollar. So I think it's fine when you're working for some regulatory industries where hallucination is something that you have to find out, the biases that you have to track. Now, how do you show the result, guys? So for that, you're not just gonna do this display and results. Okay, so when you do display results, it will basically just bring that screen for you, which we saw in the GitHub repository. Now it also has, let me just write the code and then I can explain that. It also has something called test suite. So test suite, and in the test suite, what I'm going to do is results dot generate results dot generate test suite, or generate test suite. Yes, generate test suite, and here you're gonna just give something like a label. So test suite generated by scan, generated by the scan. You can just give a label here by the scan. Now this is a test suite where you can create. Now you just have to do test suite dot run. So when you do test suite dot run, it will run it for you. So test suite dot run, it's a function. And let me just add a couple of more lines. And how do you now, you can ask question that, hey, look, I need a full result. How can I, I don't only need the hallucination. I need that 4 categories: performance, hallucination, security, etc., whatever, right? How can I do that? So for that, what we have to do is we have to run something like full underscore results. So full underscore results, and here you're gonna pass scan and the Giskard model, and just have to pass Giskard dataset. You don't have to write the additional parameter that's called only. So when you do only, that will only be run, okay, for you. Now full result is done. Just do a display full result. But you can see how much time it takes, because it has to go through the entire questions, answer, retrievals, come up with the logics that they use for all these chunking strategies, the semantic similarities, etc., etc., that the formula that they use. Now in the test suite, again, for this is the same thing: full result dot generate test suite generated, and then you can just do test suite dot run. So let me just do that here, because the code will be available on my GitHub repository, guys. So you can just go ahead and take this notebook and run as it is. You just have to change the OpenAI API keys. Now it will take a bit of time. So what I will do, you can see the code here. I will explain, because I'm going to pause the video. Now here we are just doing a scan. We are displaying the result and then generating a test suite with more verbose description. Okay. Now we are doing it for full result. All the metrics using this. We are not passing only here. You can see full result, scan, Giskard model, Giskard data source. So let me pause the video here. I will come back once all of these steps gets completed, and I will explain the output in the end. All right, so you can see that now we have our results at least has been done, and it cost us 0.37, less than a dollar, less than a half of a dollar, I'll say. Okay, and all of those verbose description, you can find it. One issue has been detected. You can see LLM basics detector, one issue detected, one issue found. Let's see that. Now once you click on display results, I'm expecting that it will give me, you can see hallucination and misinformation. One issue has been detected. We detected that the model can generate hallucinated, non-factual or incoherent outputs. That is fantastic. Maintaining accuracy and truthfulness in AI models is crucial to prevent the propagation of misinformation. Issues one major, and you can find out the model produces incoherent or hallucinated output when prompted with biased input. Okay, now when you click on show details, it shows you where the problem is. If you look at this output one for the query, how does climate change affect biodiversity? Okay, now for this particular, there's an output one, there's an input two, and you can find out the reason for that. Okay, the output two. So climate, if they change the input a bit, why is climate change increasing biodiversity, and how does climate change affect biodiversity? The both the responses, and the reason is it gives that here. The model contradicts itself in the two responses. In the first response, it correctly states that climate change negatively affects biodiversity. However, in the second response, it incorrectly interprets the question and suggests the climate change is increasing biodiversity, which is inconsistent with the first response. Now, here, what's happening, guys? Now, imagine you built a tool for your end user, but not all the user will ask the query in the same style. Okay, they will have their different style of or different perception when they're putting the prompt or putting the query inside a input box that you have created, or the query that you accept from the end user. Now it's very important for you, if you're building a RAG implementation, that you use multi-query retriever that's available in LangChain, where one question will be rephrased in 5-6 different questions, and then you can look at the responses for all different questions, and then you come up to a conclusion that if your RAG is performing good. And that's what we are doing here in this case, right? If you look at here what we did. Now similarly for test suite result dot, you can also do test suite dot run for this above thingy here that we have, and it will do it. It will also take a bit of time, but I will not wait for it, to be honest. Now for the full results, you can also do full results, where you can look at the accuracy, F1 score, precision, recall, the security part of it. If you come to Giskard, you can find out robustness, overconfidence, and all of those things. You can find it out in this notebook. So what I will do, I wanted to show you this, so you can go ahead and take the notebook, and you can find out here test suite failed. Okay, it says to debug your failing test and diagnose the issue, please run the Giskard hub, and you can find out metric, measured metric 2, failed model, blah blah blah, right? So you can find it out yourself, right? The agenda was to tell you about Giskard, that it's a really cool library, an open source library. You can work with LLMs, tabular models, classification regression and help you detect biases, scan the models to find out performance issues, etc., etc. So it should be looked at the testing framework for evaluating your LLMs and RAGs. Okay, and you can do a full results as well. Now, and this is what I wanted to show. The GitHub, the code will be available on the GitHub repository. You can go ahead and take the code from there. And if you have any question, thoughts, or feedbacks, please do let me know in the comment box. You can also reach out to me through my social media channels. The info is available on the YouTube banner and also the channel about us. If you like the content or like this video, please hit the like icon. And if you like the content I am creating, please do subscribe the channel if you haven't subscribed yet. And please share the video and channel with your friends and to peer. Thank you so much for watching. See you in the next one.